Now you're going to do some practice problems to apply what you learned from the first video. So first, I want you to graph these two functions and identify the key features. When you're identifying the key features, you're going to list where is the asymptote of the function. So if it's going along the x-axis, it's going to be where y equals 0. And tell me, is it which y values do you see, or x values? If it's going like this, where is it kind of close to? X values that are, close to this point and to the right. And then where's the asymptote? It's not always going to be along the x-axis. It could be higher or lower than that. So just identify that. Identify the steepness. How does the steepness of the curve relate to the numbers you see here in the function? And then anything else that you can notice. Is it kind of wider because of the number, or is it more like curved super fast going into a vertical line? Use as much vocab as you can. You guys can graph these in Desmos. You do not need to graph them on paper. You're going to practice graphing down here. So these can be put into Desmos exactly how you see it, and it'll graph it for you, and then you identify the features. For the next part, you're going to graph these three functions. Do them in your book, in your notebook, kind of sketch a coordinate plane, identify, what values you want to put based off of how high when you make a table, because that's the first step. Make a table. And like I said before, you're typically going to use these 5 values for x, -2 to +2. And then substitute it in and get your y values. Then decide how you want to label your graph. What's the highest y value you got here? You can put that as your top, and then what's the highest x value you can use over there. Then, after you've graphed this in your notebook, check it in Desmos to make sure that you've done it accurately. When you're done with that, come back to the video and we're going to finish this part. We don't have much left, so hang in there, guys. So we're looking at an exponential function. It's the product of an initial amount, which is a is the initial amount, and the constant ratio. Remember, this was how the table values were changing in the y, by multiplication, okay? The constant ratio, and then that is raised to a power. So for example, it's ab times x. Remember, a does not have the exponent other than 1. B is the one with the exponent of x. So let's look at this. What is the exponential function represented in the table? So we need to see the initial amount. Well, when there's nothing is an input, we're starting with 4. So 4 is our initial amount. Think of this as also being the y-intercept, right? When x is 0, y value is our y-intercept. What's the constant ratio? Well, each time it's being multiplied by 3 from the previous answer. So the constant ratio is multiplied by 3. Whoa, 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 whoa. Okay, so it's times 3. We don't have anything in front of it, so I'm not going to put like a dot. What is the function? Remember that we have our value, our formula here. F of x equals a, which is our initial value, that's 4, times our constant ratio, which is 3, that's b, and then that's raised to the power of x. X stays the same because each time we plug in a different x value, we're going to evaluate it. So let's just see if this makes sense. We plug in a 0 here. 3 to the power of 0 is 1, and 4 times 1 is 4. Let's plug in the 1. We're not going to check all of them. 3 to the power of 1 is 3, and 4 times 3 is 12. So this is how you can check to see if you wrote the function correctly. Now let's look at a graph. How can we tell what the exponential function is? How do we write it by looking at just a graph? Well, let's identify the points. Let's make a table to find the pattern. When x is 0, y is 128. So there's our starting value right there. So I'm going to just start filling this in. Our starting value is 128. This tells me that we must have a negative. We're dividing, right? Not a negative, sorry, but we're having a fraction because we must be dividing to get smaller. Next point is when x is 1, y is 64. When x is 2, y is 32. You can see what's happening, right? It's being cut in half. When x is 3, y is 16. I think we're good there. We found the pattern. It's dividing by 2 each time, which means that our b value is 1/2. Increases by 1, but divides by 2. That's 1/2. That's a half. So this is kind of like finding our slope, right? Then this is taken to the power of x. So again, you can check this. You could use a calculator, or you could rewrite this as 2 to the power of -1. That's 1/2. And then use that each time you're plugging in the values for the exponent and then multiplying it times 128 each time. But that would be how you check that. So that's how you write from a graph. Make an XY table for your x and y values to find the pattern, the starting point, your a, b values, and your x is your exponent. Same thing with this. I'll do the first one with you. So say you're given a list of points. Well, we know that it's our x and y values. So let's look. When x is 0, y is, no, my bad. When x is 0, y is 3, which means our starting point is 3. That's our a value up here. Now go from y to y to find the pattern. 3 to 12, 12 to 48, 48 to 192. We can see that it's being multiplied times 4. So that is our b value risen to the exponent of x. So 3 times 4 to the power of x is our function. So do the same thing here for this one. Again, if you're starting with bigger y's and going down, it must be a fraction for your base, for your exponent. After that, I want you to compare these. You can graph them, you can check them in Desmos, but write the function for each one and then graph it in Desmos and see what it looks like and compare them. It's saying which option will increase the pledge amount faster over time. So you want to make sure that you're looking at, and you can see it here over time, but it's, I want you to graph it to really see how much it's going to grow as these weeks continue on. Then you're going to work on these. Is it linear or exponential? So if it's a pattern of addition in the table or the values, it's linear. If the pattern is multiplication, it's exponential. And then you're done.